Since we've done addition and subtraction of polynomials, now it's time for multiplication and division. We're going to do multiplication first, then we'll handle division later. So remember this. If I have two numbers that are raised to powers but they're to the same base, then you can add the exponents. So that's what I'm going to be making use of here. So as an example, suppose I have 2k to the 6th times 7k to the 3rd. I actually want a different number up there. You could use the commutativity property to move the numbers in front and then worry about the exponent. So I have k to the 6th times k to the 3rd. 2 times 7 is 14. And then k to the 6th plus 3. We get 14k to the 9th. Make my 9 a little better. So basically what I did is I concentrated just multiplying the numbers together and then multiplied the variables together. Let's do it again. Another example. Negative 2/9 z to the 3rd times 3/4 z to the 9th. I can put the numbers together, so negative 2/9 times 3/4, and I'll have z to the 3rd times z to the 9th. So then the number parts, I can do what I normally do with simplifying. So I'll get a negative 1/6 from the numbers, and then the law of the exponents will tell me that I got z to the 12th. 3 plus 9 is equal to 12. So we're going to be making use of a lot of that kind of stuff. And then recall the distributive property. That's the one that looks like this. If I have a number times a sum, so something like a times b plus c, then I can multiply the a through to both parts. Something like this. I usually draw something like these a little diagram like that to indicate that that's the distributive property. So as an example, if I have 3y times 10y minus 1, I can take the 3y times 10y. So the 3y times 10y minus, and then I can do the 3y times 1. The 3y times the 10y, I can concentrate on the numbers. 3 times 10 is 30. Y times y is y squared. And then the other piece is just minus 3y. Another example. Negative 4h to the 7th power times 5h to the 6th plus 4h to the 3rd plus 11h minus 3. When I use the distributive property, I've got to take this thing and multiply it by all four pieces in the parentheses. So I'll get negative 4h to the 7th times 5h to the 6th minus 4h to the 7th times 4h cubed minus 4h to the 7th times 11h. And then finally the last one, since I'll have two negatives, minus times minus will be a plus. I'll have 4h to the 7th times 3. Let's see what we get for each of these things. For the first pieces here. Negative 4 times 5 is negative 20. Now when I have h to the 7th times h to the 6th, remember 7 plus 6 is 13, so that's h to the 13th. For my next, 4 times 4 gives me 16. H to the 7th times h to the 3rd is h to the 10th. Then we have negative 4 times 11, so I get negative 44. H to the 7th times h to the 1st. So if you need, put a little 1 up there to help yourself remind. I'll get h to the 8th power. 7 plus 1 is the 8. And the last one, all I have to do is multiply the numbers together, and I'll get 12 h to the 7th. Another example, a little more complicated. I'll give myself some more room. Here we have 4x to the 6th y squared times negative 5x squared y plus 11x y squared minus xy plus 2y minus 1. So now I've got to distribute all that stuff to each and every piece inside of there. That's a total of, what, 5 pieces? So the first piece will be the negative because of that. Now I'm going to just concentrate on just the numbers and the variables. So when I do this times this piece, I'm going to have negative 20 because the 4 and the negative 5. Now what I'm going to do is, at the same time, I'm going to arrange my x's and y's. I have an x to the 6th times an x squared will give me an x to the 8th. And then I have a y squared times y to the 1st will give me a y to the 3rd. And now I'll go ahead and move on to the next piece. Both pieces are positive, so I don't have a minus sign to worry about. First, I'll start with 4 times 11 is 44. X to the 6th times x to the 1 will be x to the 7th. Y squared times y squared will be y to the 4th. Now the next one I have a minus. The number in front of xy is just 1. 4 times 1 will just be 4. Now once again, x to the 6th times x to the 1 will be x to the 7th. Y squared times y will be y to the 3rd. And that takes care of that piece. Now moving on from this number all the way, or that term all the way down here to 2y. Well, the 4 times 2 will give me an 8. This is positive. X to the 6th, well, there's no x there, so we're just going to get x to the 6th. And then y squared times y to the 1st is y to the 3rd. And then finally, we have the very last one, which is just negative 1. So all we're going to get is negative 4x to the 6th y squared. So that gives you a little bit of practice with the distributive property. We're going to make use of it substantially in this section to develop some of the rules for our multiplications. One last distributivity type problem. I'm going to have 3/4. Nothing would be complete without throwing fractions into the mix. I'm going to have 12t cubed minus 20t squared plus 9. So I'm going to multiply to each and every single piece inside of the parentheses. And so when I do the very first one, 3/4 times 12, I'll go ahead and write these out. 3/4 times 12, probably a good idea to put it as 12 over 1. But then I have t to the 5th times t cubed will be t to the 8th. Next, I'm going to go on the next one. I'm going to have 3/4 t to the 5th times negative 20t squared. So I'm going to have a minus. The number part, I'm going to have 3/4 times 20. I'll put 20 as over 1 to make that easier. T to the 5th times t squared is t to the 7th. And then finally, for the last part, I don't have any t to pair it up with, but I do have 3/4 times 9. I'll write it as 9 over 1, and the t to the 5th is along for the ride. So let's see what kind of simplifying we can do here. 4 goes into 12 exactly 3 times, so I'll get 9t to the 8th. Let's see, 4 goes into 25 times, so I'll get negative 15t to the 7th. On the last piece, I noticed that 4 doesn't go into 9, so there's no simplifying I can do. I can simply write this as 27 over 4 t to the 5th. And now we're ready to work this a little bit more. If I were to give you something like this, you would take that smiley face and multiply it to each piece inside of there, and you would get 5d times the smiley face plus 9 times the smiley face. So no matter what smiley face is, that rule is appropriate. So I'm going to use a similar kind of a smiley face when I do the following. This time I want you to think of the whole expression d plus 8 is like my smiley face. So I'm going to take this whole thing here and I'm going to multiply it to the first piece and the second piece. So I'm going to use the distributive property to get that. So I will get d plus 8 times d. There's the first part. And then I'm going to get d plus 8 times 8. Now let me go ahead and multiply it out. Now you're going to have to use the distributive property in this direction now, since d is multiplied to both parts and 8 is multiplied to both parts here, so you're going to have to use the distributive property for that. So what I'll get is d squared plus 8d plus, and then I'll get a d8, which you can just call 8d, and then finally 8 times 8 is 64. So I get d squared plus 16d plus 64. Let me do it again. Suppose I were to do d plus 8 times 5d plus 9. Once again, I take this whole chunk and times it to each piece of the second. And so I get d plus 8 times 5d plus d plus 8 times 9. Now I use the reverse distribution to get 5d squared plus 40d. And I'll do the same thing over here. I'll get plus 9d plus 72. And that equals 5d squared plus 49d plus 72. So now let's compare that last result with the following. I'm going to write up a shorthand notation that goes like the following. I'm going to do all of these moves here. If you noticed, we distributed twice, and then we distributed one time, and then we distributed 2 more times in the other direction. We can accomplish all of it in once by looking at the following. I take this first d and I multiply it to 5d. This is what we call the first. The acronym I'm coming with you probably are very familiar with, but I'm going to write it down nonetheless. I do want to keep my results up there. So I get 5d squared from that multiplication. Now then, I move on to this d out here all the way over to times that 9. This is what we call the outer. So from that, I'll get a 9d. Next, we do these things on the inside, which we call the inner. And that part there, 8 times 5d is 40d. And then finally we take this last one times this last one there. That'll be 72. That's 8 times 9. I'll just write 72 for that part. That's known as the last. And you can see the acronym that is spelled out is FOIL. So you probably are familiar with the FOIL method. But I want you to see that it is the same thing as before. Look at this expression here when we multiplied it all out and compare it to the multiplied out version over here. The only thing that's different is the stuff inside, and the middle pieces, well, it's the same because you can add in any order that you want. So this up here is identical to this down here. So the FOIL method is what we're going to be using for our multiplications. So let me go ahead and finish off this problem and then move on to the next example. So for the rest of this program, I'm going to be doing the FOIL method for all of my multiplications. U plus 5 times u plus 3. It's probably not a bad idea while you're doing your multiplications to do this. F-O-I-L until you get comfortable with this. And so when I do the F, that's this, the first part, that's u times u will give me u squared. So I can kind of do this as I'm working out the acronym. The next thing we do is this first u times that last 3. That's what they call the outer part. They were both positive, so you get a 3u for that one. The next is still positive. I have a positive 5 and a positive u for the inner part. There's 5u. And then finally, to finish it off, we do these lasts. I get 5 times 3. They're both positive, and that's 15. And then all that's required now is to simplify by combining like terms. So I get u squared plus 8u plus 15. Once again, I'll do the same thing as I did. I'll put my F, my O, my I, and my L, and keep doing it until you get comfortable. Start with my F, that's the u times u. So I get u squared. Now I got some minuses now. Then for my O, I have u times negative 4, so I got minus 4u. And then for my I got negative 12 times u. And then finally, for my L, I have negative 12 times negative 4 is positive 48. So let me go ahead and combine my like terms. U squared minus 16u plus 48. Moving on. Let's see, start with my f. That's g times g will give me g squared. Then for the outer, I'll do g times -8, -8g. For the inner, I'll get positive 4g. And then for the last, I'll get -32. And that equals g squared minus 4g minus 32. Let's see, for the next one I have 5x plus 1 times x plus 7. Multiply out. Let me start with my f. 5x times x is 5x squared. And then I'll start with, then I'll have my outer. 5x times 7 is plus 35x. Then I'll have my inner, which is 1 times x, that's just x. And then finally my last is 1 times 7, which will just be positive 7. Simplify, 5x squared plus 36x plus 7. Next, 2 minus 3r times 4 minus 5r. Same deal. Start with the first. 2 times 4 is 8. Then the last, 2 times -5r is equal to -10r. And then the inner, -3r times 4 is -12r. And then finally the last, -3r times -5r is positive 15r squared. And then just simplify the middle terms. 8 minus 22r plus 15r squared. Now I want you to know that there is nothing wrong with the answer. In fact, it's perfectly correct. But most of the time, you'll see them write the answer like this. Both of these are the same thing. It's just one is written in a different order. A lot of times, people like to write the powers from highest power going downward. For whatever reason, it has no bearing on whether it's right or wrong. It's just for convenience, depending on what type of problem they're working on. I'll usually do that myself just because it seems more natural to me. All right, next we have 0.5p minus 0.3q times 0.7p minus 0.4q. And I'll start with my first. I'm going to get 0.5 times 0.7. Remember, 7 times 5 is 35, but you move the decimal to the left 2 places because you have 2 decimals. And you'll end up getting 0.35 for the number part. But then p times p is p squared. And then I'll go ahead and do the outer part. I'll have a negative since it's positive times a negative. 0.5 times 0.4 is 0.2. And then I have a PQ. Then the inner part, 0.3 times 0.7 is 0.21, and it will be negative. And once again, I have a PQ. I have QP actually, but I can reverse it and make it PQ. And then the last, this to this, 0.3 times 0.4 is 0.12. It's going to be positive 0.12, and Q times Q is Q squared. And to finish off the problem, all I'm going to do is collect the like terms in the middle. we have negative 0.2, negative 0.21, that's negative 0.41 PQ plus 0.12 Q squared. Okay, now let's see what we get here. I'll do my first. So I'm going to 3/4 x times 1/3 x. Let me put the 3/4 times 1/3 here. X times x will be x squared. Then I'll have my outer. I'll have, those will be positive because I'll have 3/4 times 4. I'll put a 4 as 4 over 1. Then I have an x y squared. Then the inner, I'm going to have negative 1/3. It looks like y squared x. I think I'll write x y squared just so it also looks like this, so that they are, it's no doubt that they're like terms, is why I did that. And then finally the last is going to be negative also, but I have 4 y squared times y squared will be y to the 4th. And let me simplify all that I can to come up with my final answer. These 3's will cancel, and I'll get 1/4 x squared. These 4's will cancel, so I get plus 3xy squared minus 1/3 xy squared minus 4y to the 4th. So the only thing I got to do now is simplify this stuff inside of here. So if I've got to do 3 minus 1/3, it's better to think of that as 9/3 minus 1/3, or 8/3. And so for my answer, I get 1/4 x squared plus 8/3 xy squared minus 4y to the 4th. Now comes a situation that this is my own word. You won't find it anywhere except in my notes. I'm going to call it superfoil. And it works like this. Here, let's say I have as an example k minus 2 times 9k squared minus 4k minus 12. Well, what you do is what you think you should probably do. I'm going to do my first times the first, so let's do that part. That'll be 9k to the 3rd. But then I'll take it and do it. There's no acronym letter for this one. It's something like in the middle. Maybe these are all like inner terms or something like that. But then I go k times negative 4k will give me negative 4k squared. And then I'll do k times negative 12 will give me negative 12k. Then I'll move on to the other piece from the first parentheses and start doing this. So I get negative 18k squared, and then I'll do this. That will give me plus 8k. And finally, this piece all the way to here will give me plus 24. Well, as you can imagine, there's a lot of like terms inside of here. For example, look what I've got. I've got a 4k squared and I've got an 18k squared. So I can combine those to give me negative 22k squared. And typically, while I'm doing this, I usually slice them off so that I know that I've already used them and it won't confuse me going forward. The next things I'm looking for are negative 12k and positive 8k. That gives me negative 4k. So I can slice those off. And all that's left is then plus 24. more superfoiling. Here I have 3m to the third plus 3m squared minus 4m minus 9. I'm going to multiply it times 4m minus 7. So we can do, just like before, I can even do here, I'm going to do this guy times the first, and then this guy times the second. So that'll be, let's start with the first. 3m cubed times 4m will be 12m to the fourth. And then I'll have 3m cubed times negative 7. That will be negative 21m to the third. Now I move on to the next item here. And it's kind of hard to see as I do this, but I'm going to take it times the first item. That will give me 12m cubed. And then I'm going to take it times the negative 7. So that will give me negative 21m squared. Now I'll move on to the negative 4m. Negative 4m times negative, or positive 4m is negative 16m squared. And then negative 4m times negative 7 will be positive 28m. And then I'm finally ready for 9. Negative 9 times 4m will be negative 36m. And then negative 9 times negative 7 will be positive 63. Now let's go ahead and simplify by collecting like terms. I don't see any other m to the fourths except the first one. But for m to the thirds, I see a negative 21 and a positive 12, and I see no other m to the thirds after that. So I have negative 9m cubed. Let me go ahead and cancel those. Now of the m squareds, I have negative 21 and negative 16. That's negative 37m squared. Then 28m minus 36m will be negative 8m. And then finally the 63 was on its own. Now, I want to redo this last example, but show you the way that I do it and keep track of my results. And I'll see if I can give myself lots of space here. 3m cubed plus 3m squared minus 4m minus 9 times 4m minus 7. So I'm going to redo this whole thing, and I'm going to start with my first, just as before, that's 12m to the fourth. And then I'm going to do that same thing times the last. That'll be negative 21m cubed. Now watch what I do next. My next one, the 3m squared times the 4m is equal to 12m cubed. I'm going to put it underneath of here. And what I'm going to do is keep track of my like terms without having to do that stuff that I was doing before where I slice off a bunch of things and whatnot. Anyways, 3m squared times negative 7 will be negative 21m squared. And now I'll move on. Negative 4m times positive 4m will be negative 16m squared. See how I snuck it under the other m squared. Negative 4m times negative 7 is positive 28m. And now let me go ahead and finish off here. Negative 9 times 4m will be negative 36m. And then finally, negative 9 times negative 7 will be positive 63. And then what I have here are a bunch of numbers to add up, just like you would regular multiplication. And they're even marked out sort of like in place values. So all I have is the 12m to the fourth had nothing else to add to it. But now when I look at the m cubes, negative 21 plus 12 is negative 9m cubed. Negative 21 minus 16 is negative 37m squared. 28 minus 36 is negative 8m plus 63. I am a big advocate for this particular breakdown because it really helps simplify the problem in my book. You do not have to do that. You can do something like this. Most students do a version of what's up here. A few students do this kind of stuff. So you pick the way that's most comfortable for you, but I like this particular way, and that's the way I'm going to do the rest of my examples. So we will go to n to the fourth plus 8n squared minus 5 times n squared minus 3n minus 4. And let me multiply it out. So this is everything times everything. I don't know how else to describe it, but I'll start here with my n to the fourth times n squared. I'll get an n to the sixth. Then I'll move on. N to the fourth times negative 3n will give me negative 3n to the fifth. Then n to the fourth times negative 4 will be negative 4n to the fourth. So that takes care of the first number, or first entry. Now I'll move on to the second piece. 8n squared times positive n squared is 8n to the fourth. So I'll put a plus 8n to the fourth underneath my previous n to the fourth. And then we're going to have 8n squared times negative 3n. That's negative 24n cubed. And that not quite yet. Then I have one more piece here, 8n squared times negative 4. That'll be negative 32n squared. And now let me start doing these, sort of like inner terms, if you will. Negative 5 times n squared gives me negative 5n squared. The next one gives me positive 15n. And then finally this last piece here gives me plus 20. We go ahead and add all those up. N to the sixth minus 3n to the fifth. For the n to the fourths, I get negative 4 plus 8, so that's plus 4n to the fourth minus 24n cubed. Then I have negative 37n squared plus 15n plus 20. Let's try x minus 1 times x squared plus x plus 1. Here, I'll add x times x squared is x cubed. X times x is x squared. X times 1 is x. And then move on to the negative 1. Negative 1 times x squared is negative x squared. Negative 1 times x is negative x. Negative 1 times positive 1 is negative 1. Add them together, and you see that the x squareds cancel and the x's cancel, and all I'm left with is x cubed minus 1. The rest of this is going to just involve variations on exactly what I just did. Check this out. I have 4 times 7 minus 3z times 2z minus 1. Now the way you multiply it out is your business. But what I'll do is I'll first multiply the 4 through here and get 28 minus 12z, and then I'll multiply it times 2z minus 1. So this then, this is straight up FOIL. The f will give me 56z. The o will give me negative 28. The I gives me negative 24z squared. Don't forget that. And then my last will be plus 12. Now, for some reason, do I have anything to combine? I do have the negative 28 and the 12. And like I said, I usually put the highest power first. But the negative 28 and the positive 12 give me a negative 16. It looks like I have plus 56z minus 16. So let me check that out. I think I may have made a mistake. Let me check. 28 times 2z is 56z. Good job there. 28 times 1 is, negative 1 is, well, negative 28. Negative 24z squared. I see where it is here. When I did the last, negative 12z times negative 1, that's a positive 12z. So that messed up my numbers a little bit. Let me clear this up. The 24z squared wasn't a problem, but I did have 56z and 12z, and then a minus 28. Next we have negative 7r squared times r minus 9 times r minus 2. For students, I believe it is desirable for them to multiply out these things first and then multiply the 7r squared. It does not matter. You can multiply this first and then do the FOIL method. You could do the FOIL method first and then multiply. It absolutely doesn't matter. I'm going to simply go from left to right like I normally do, using the order of operations. So the negative 7r squared times r will be negative 7r to the third, and then I'll have negative 7r squared times negative 9 will be plus 63r squared. And then I'll apply the FOIL method to the resulting expressions. So let's start here. I'll get negative 7r to the fourth, and then here I'll get positive 14r to the third. Underneath here, I'll get 63r to the third. And then here, I'll get negative 126r squared. I'll add all these together. So negative 7r to the fourth plus 77r cubed minus 126r squared. Here, a little more complication. What I'm going to do is take these first two parentheses first, and then I'll leave that guy till the end. So I'll start with x times x. I'll get x squared minus 2x minus 5x plus 10. That's the first set of parentheses. Don't forget there's an x plus 3 after that. If I simplify in those parentheses, I'll get x squared minus 7x plus 10 times x plus 3. And now here comes one of those super FOILs. I'm going to do x squared times x, so I get x cubed, then x squared times 3 plus 3x squared. Then at negative 7x times x will be negative 7x squared, and I violated what I just said I would do. Negative 7x squared. And then negative 7x times positive 3 will be negative 21x. Down here I'll get plus 10x plus 30. And let's add them all up. I'll get x cubed minus 4x squared minus 11x plus 30. Next I have x plus 1 times x minus 1 times x squared plus 1. So for this, I'll start with these parentheses again. I'll get x squared minus x plus x minus 1 times x squared plus 1. Those middle x's cancel and I get x squared minus 1 times x squared plus 1, which is nice because it's a binomial times a binomial. The FOIL method is perfect for this. So I do x squared times x squared. I'll get x to the 4th. X squared times 1 will be plus x squared. Negative 1 times x squared, negative x squared. Negative 1 times 1 will be negative 1. And my final answer is x to the 4th minus 1. This leads me to a collection of things called special products. I'm not a huge fan on these because it does mean memorizing more stuff, and you don't have to memorize any of these things. You can simply use the rules that we've already developed. All I'm going to do now with the special products is come up with extra rules that deal with certain situations. So look at this last one. That's the one that I'm interested in. And look at this. If I take x plus y, x minus y, and multiply it out, let's do this. I get x squared, but then when I do this, I'll get negative x times y, but in here, I'll get positive x times y, and then finally, minus y squared. Well, look what happens to the xy terms. They disappear. So this product is called the difference of squares. And if you want, you can memorize this. After a while, it depends on how long you intend to do math after this course. But if you do math for any length of time, products like these will just be ingrained into your memory after a little bit. Let me do an example to illustrate this. Here we have 5y minus 4 times 5y plus 4. And according to the rule I just developed, 5y is playing the role of x in that rule. So look at this rule up here. Whatever comes first, you have that thing squared. So 5y comes first in each piece. My second part here is played by the 4. So I'm going to get minus 4 squared. So I have 25y squared minus 16. So it can make things a little bit faster. Once again, if it's something that you're comfortable with and something that you're used to, you can really save yourself a lot of time with these rules. So you can see this is similar to the previous one. I got a 4x at the beginning of each, then I got a negative 11, and then a positive 11. So I can use my difference of squares formula. 4x squared is 16x squared, and then 11 squared is 121. Next, b minus 1/5 times b plus 1/5. That equals b squared minus 1/5 squared. And that simplifies to b squared minus 1 over 25. 5 squared, of course, is 25. For the next one, I have 1.2a plus 0.8b times 1.2a minus 0.8b. So you can see it is a difference of squares type of a formula. I'll have 1.2a squared minus 0.8b squared. 1.2 squared is 1.44. 0.8 squared is 0.64. And there you go. So difference of squares, pretty easy one. Most people enjoy that one. This next one, I don't know what you know, a square binomial. In fact, better than this, what they refer, the notation that's used is this: perfect square trinomial. That means something with 3 terms is coming, but where is it involved at? And I'll show you. Suppose I take x plus y to the second power. One thing that students many times try to do is this. And unfortunately, there is no rule like that. This is absolutely wrong. I don't know what I can use, but this is wrong. No. The only way to do this properly is to write x plus y squared as x plus y times x plus y and do the FOIL method. So when I do that, I get x squared plus xy plus xy again plus y squared. This gives me x squared plus 2xy plus y squared. This one is not nearly as much fun to memorize as the other one. And to be honest, I don't bother memorizing it, but if you go into a future class, you'll hear them say things like perfect square trinomial all the time. And what they're looking at is the result. This here, right here, is a trinomial. If you can somehow notice that the first term is squared, the second term is squared, the last term is squared, but the middle is twice the beginning and the last, then you're in business. But that's not always easy to see. And for the most part, it's not a formula that I personally memorize. But nonetheless, let's go ahead and use it for a couple of examples. The book and other instructors seem to think that it's important. So let's do b plus 6 squared. And I'll use the formula right above it. So now the b is playing the role of the x and the 6 is playing the role of the y. So according to this rule, I'm supposed to have b squared plus 2 times xy. The x is b, the y is 6. So I'll have 2 times b times 6. This makes it so that it's exactly in this formula. Y is playing the role of 6. Plus 6 squared. That's b squared plus 12b plus 36. Next we have 7n, well, I don't care, 7m plus 2 squared. According to my formula then, I'll put it back here. The first piece squared, so 7m squared plus 2. Now 2 times the first chunk, 7m, times the second chunk, 2, or entry, whatever it is you want to call it, and then plus the second entry squared. And so I get 49m squared plus 14 times 2 is plus 28m plus 4. With the minus sign, you're going to have to adjust your the first term is 3p, but the last term is actually -5. So it will come into play as I do my next thing. 3p squared. This time you're going to get minus 2 times 3p times 5 plus, this last part doesn't change, 5 squared. The only thing that changed was the middle part. 3p squared is 9p squared minus 30p plus 25. And then many of the last examples here are just going to be sort of imaginative explorations of the rules as we've developed them so far. So here we have 3r plus 2 minus t, that whole quantity is squared. So when I use my formula, let me write it back up here. X plus y squared is x squared plus 2xy plus y squared. And in fact, I'll make it a little easier on myself. Let me put a minus here so that it changes that part to a minus. And let's use that format. So the role that is playing x here is actually this 3r plus 2. So I have 3r plus 2 squared. So this is like the x, and this is like the y in my formula. Y actually is negative. Well, no, y can be viewed as t. That's fine. The minus sign is already standing there. Now, according to the rule, I have to do -2, and I have to do x. The x part was the 3r plus 2. And then I've got to do y. My y here was the letter t. And then finally, plus t squared. All right, what I'm going to do next is this guy right here, I'm going to use the FOIL method on that, but I'm going to use the formula that we developed before. So for that piece right there, I'm going to get 3r squared plus 2 times 3r times 2 plus 2 squared. So that piece is responsible for that. Now what I'm going to do next is I'm going to multiply this, start to multiply this out. So I get 6r plus 4 times t plus t squared. 9r squared plus 12r plus 4. Now when I multiply this through, I'm going to multiply the t. I'm going to distribute the t but the negative at the same time. So I get negative 6rt minus 4t plus t squared. And now I want to scan through and see if there's any like terms that I might need to deal with. And I don't think that I have any like terms, so this is finished. -3 times m minus 1 squared. I'm going to FOIL out the m minus 1 first to get m squared minus 2 times m times 1 plus 1 squared. Now when let me do one more step of simplifying the parentheses. And now I'll go ahead and multiply -3 to each in every piece inside of that parentheses, and I'll get negative 3m squared plus 6m minus 3. Next we have w plus 4 to the third power. We don't have any special product formula for w plus 4 to the third. Instead, I'm going to treat it as w plus 4 squared times w plus 4. And then I'm going to multiply the squared part out first. So that part right there, that will be w squared plus 2 times w times 4 plus 4 squared times w plus 4. Before I multiply it all out, let me go ahead and simplify inside the parentheses a little bit. Like so. Now I'm going to do my superfoil. So I'll start with w times w squared. That'll be w cubed. Then w times 8w. 8w squared. W times 16. And now I'll move on to the 4. So I'll start with 4 times w squared. I'll tuck it underneath the other w squared. Then I have 4 times 8w. And then you'll do 4 times 16. And then when I add them all together, I get w cubed plus 12w squared plus 48w plus 64. Here's a problem that I saw in the textbook that I thought was kind of interesting. I think it might be useful if I could draw a couple of pictures to illustrate this. So let me, it was just out of the textbook I saw one, and I want to do one like it. What they had was the following. They had a rectangle like so, and then inside of it they had actually a square inside of it. I'll see if I can reproduce the square. Well, it doesn't matter whether it looks like a square or not. Let me give you what we had for the dimensions. On the outside, this length here was 5x plus 3. Here was 5x minus 3. And then for this length was x minus 1, and the height was x minus 1. As I said, it was supposed to be a square. What they've done is shaded the entire rectangle except that particular square. So this was a problem, like I said, out of the textbook. So compute the area of the shaded region. So what it is then, the way you can do it is you can take the area of this outer rectangle and then simply subtract off that area that's missing. So what I'm looking at doing here is 5x plus 3 base times height, that's the area of the outer rectangle, minus x minus 1 squared, that's the area of the square inside of it. So when I subtract out that blank spot, that will give me the area of the shaded region. Well, this here is a difference of 2 squares. So we know this to equal 5x quantity squared minus 3 squared. For the second piece, it's a piece squared. So you're going to get x squared minus 2 times x times 1 plus 1 squared. Let me go ahead and simplify a little bit. 25x squared minus 9. Let me make that square a little bit better looking. Minus, and then inside of here I have x squared minus 2x plus 1. So let me go ahead and distribute the negative through. I'll get 25x squared minus 9 minus x squared plus 2x minus 1. Make sure it's like multiplying negative 1 through to all three pieces. For my x squareds, I have 25 and negative x squared, so I have 24x squared. So I can slice those off. I have no more x's except just the 2x. So that takes care of that one. Then negative 9 minus 1 looks like negative 10. Let's try b plus 3 raised to the 4th power. And once again, I'll treat this as b plus 3 squared times b plus 3 squared. And we have formulas for those. B squared plus 6b plus 9 times b squared plus 6b plus 9. This time I've not told you how I did it. I expect you to go and try to figure out how I got these numbers. Now I'm ready for a superfoil. So I got b squared times b squared will be b to the 4th power. Then b squared times 6b will be 6b cubed. And then b squared times 9 will be 9b squared. And then I'll move on to the 6b. 6b times b squared is 6b cubed. 6b times 6b is 6b squared. I should make this look like a 2. Then finally 6b times 9 would be 54b. And then I'm ready to run the 9s. So we have 9 times b squared will be 9b squared. Then 9 times a 6b will be 54b. And then 9 times 9 will be 81. Let's add them up. b to the 4th, I have 12b cubes. I have, of the b squareds, let me see, I have 9 plus 6 is 15, 24b squared plus 108b plus 81. Let me check out my b squareds again. And when I do that, let me see. I think I have an error in this second row, so let's check it. That's where I was doing the 6b, right there. Here, 6b times 6b is actually 36b squared, so I did make a mistake there. Let me fix my b squareds. 36 plus 9 plus 9 is 54. And the rest of the numbers I think are okay. So I'll circle it and finish it off. So these last couple of examples are just testing to see how well you grasp the material. Let's say I have 4p plus 3q plus 1 times 4p plus 3q minus 1. And I want to multiply this out. Well, you can see it's got the difference of squares format in it. So 4p, so if we have x plus y times x minus y equals x squared minus y squared. The system here is this 4p plus 3q is playing the role of x, and the y is being played by 1. So I'm going to get 4p plus 3q, that thing squared, minus 1 squared. Now to handle this part of it, 4p plus 3q squared, I'm going to use that formula. I'll get 4p squared plus 2 times 4p times 3q plus 3q squared minus 1. Looks like 16p squared. The middle part, let me see, would be 824pq. Then I have plus 9q squared minus 1.